All right, boys and girls. Today we did a foldable. So here's kind of what the foldable looked like. We did a little the magic. I don't know what you call it, magic foldable, where you have like the two intersections that are uh, secret, and you get to fold it open and that. Come in, see me. I can show you how to do it. It's real easy. Anyway, today we're talking about rationals. There's 3 days of graphing that we're gonna do. Um, Today's real easy. Just a couple things. On your homework, you're only asked to do 3 of the 4 things that we're going to do in the notes, so it's even easier. The first thing, what a rational is just a binomial, a polynomial divided by another polynomial. So if you look at your homework, you got x squared plus 5 over 2 minus x, or anything, anything over another thing that's got a variable in it, that's a polynomial. All right. First thing we're asked to do is look at our asymptote. So a vertical asymptote is always x equals 0, and we always look to see when the bottom equals 0 because we cannot divide by 0. So if you look at our first example, if I set the bottom equal to 0, or think about it, what number is going to make our bottom be 0? That means my vertical asymptote, VA, is x equals, because it's always x equals, and then that number, 6. Now, for our domain, if we think about what our graph looks like, rational function, it's been a long time, but it kind of looks something like that. So if we say our vertical asymptote is at 6, right there, that means my domain is going to be everything but 6. So we're going to say negative infinity to 6, union 6 to infinity. We're going to do interval notation, okay? The next thing is our horizontal asymptote. Now you have 3 options, but you can only have one of these 3. So it's either y equals 0, y equals a number, or there's not one, and we say it's undefined or does not exist, or 0, the O through the line through it, whatever. To determine what that is, we first look at the degree. So remember, degree is the highest exponent in the polynomial on top, highest degree in the polynomial at bottom. So if p of x has a smaller degree than q of x, then we say that's a top less the bottom, so the top is a smaller number than the bottom. That's going to be y equals 0. So for number 1, we don't have any x. That's like saying x to the 0 over, and then this is x to the first power, so the bottom is more than the top, so that means it's y equals 0. So same idea here, if we're talking about y's now, range, we go bottom to top, so it's everything but 0. Cool? All right, my second one. So all the other stuff is applicable here. So my second example, I got negative 3x plus 1. So if I want to figure out where the vertical asymptote is, just set it equal to 0. Or think about what number times negative 3 plus 1 to give me 0. And that's going to be, x equals 1/3. All right? So x equals 1/3, that means my domain is everything but 1/3, so negative infinity, comma 1/3, or sorry, yeah, comma 1/3, union 1/3 to infinity. Sorry, this is terrible. It's so small. My bad. My horizontal asymptote here, okay, well, I have x to the 1, x to the 1, so that's our next option. If degree of px is equal to q of x, then it's y equals a number, and that number, it's a number sign, is the ratio of the leading coefficients. So ratio of the leading coefficients, 6 over negative 3, so it's y equals negative 2. So that means my range is everything but negative 2. All right, and as you can see, our domain and our vertical asymptote, 6, and then 6 is there. Here was 1/3 and 1/3, and then horizontal asymptote, negative 2 and negative 2. So those numbers are always going to be the same. Last thing, horizontal asymptote, vertical asymptote. Vertical asymptote is negative 1. So that means everything but negative 1, so negative infinity, negative 1, union negative 1 to infinity. My horizontal asymptote, this time my 2 is top heavy, right? Top bigger than bottom. So that means I don't have one. So that means if I don't have one, it's going to be negative infinity, positive infinity. All right, good luck. Take your time. Please don't make this overcomplicated. It's very straightforward. Good luck. See you tomorrow.